Kavya from 9th Olympiad and I'm studying in Narayana School SMPSG at Tirupati. Okay. Have you ever wondered why a large ship floats on a top of sea when a small stone gets sink into it? I know you are so curious to know the reason behind this. But to understand these kind of things, we have to learn about fluid and its properties. So today I'm here to present you a seminar on topic fluid mechanics. So without further delay, let's get into this. First, fluid. What does fluid actually mean? The substance which is not stable and has ability to flow is called fluid. The major examples of fluid in our daily life is air and water. And what is fluid mechanics? It is a branch of science which deals with behavior of fluids in rest as well as in motion. And fluid statics deals with behavior of fluids in rest, and fluid dynamics deals with behavior of fluids in motion. And to learn about fluid dynamics and fluid statics as well as fluid mechanics, we have to know some important factors. They are density, thrust, pressure, buoyancy, and etc. etc. So first, let's get with density. Density is defined as mass of a substance per unit volume, and it is written as mass by volume. So, as we know, SI unit of mass, we take it as kilogram and volume, meter. So, SI unit of density is kilogram per meter. And CGS unit will be gram per centimeter cube. And density is a scalar quantity. So, and let's see other. It is relative density. Relative density is taken as density of a substance to the density of the water at 4 degrees Celsius. It will be written as density of a substance to the ratio of density of water at 4 degrees Celsius. Yeah. Now, as we know, density is mass by volume. Now let's do some funny case studies. Density, and also density is denoted by symbol rho. So, in our case study, first let's take some examples. For example, we have two substances called A and B. So, the density of the substance A is taken as rho 1 and density of the substance B is taken as rho 2. And mass is M1, M2. Volume V1 and V2 respectively. So, and imagine we have a big beaker and we have mixed these both substances in this beaker. So what do we get? We get a mixture by those substances. So to find the total density of this mixture with the help of these substances will be written as total density is equals to M1 plus M2 by V1 plus V2. I have told you, right, we are going to do some fun case studies. That is, for example, if we know only the density and masses of the substances and if we don't know the volume, still we can solve this problem. But how? Let me show you. Then the total density will be equals to m plus m1 plus m2, and as we don't know the volume, we take it as, we know rho is equals to m by v. So we shift this from here and this one is to here. Then it will be v is equals to m by rho. So we got the value of v. So we substitute this value here. So m1 by rho 1 plus m2 by rho 2. And in other case, if we know the density and volumes of the substance and if we don't know the masses of them, then still we can solve the problem in other manner. Like total density will be is equals to, as we don't know the masses of that, C. We take this V here. So that time rho will be equals to M. So we got the value of M. And we substitute this here. Then it will be V1 rho 1 plus V2 rho 2 by V1 plus V2. Yeah, I hope you understood this. And still, let me go a further step. Like, if the masses are same in these two conditions, in these two substances, then we take the mass just as M. So, let me apply this in the first one. Like, if the masses are same and we know the masses and just the density, but not the volume, how do we solve it? Density will be equals to M plus M. I took M in the same, I took M in both the same in both the cases because mass is same in both the substances. And we write it. See, we are going to substitute this, right? So we have to write in same manner. M by rho 1 plus M by rho 2. So, how can we further solve it? Let me show you. As we added 2 m's, we get 2 m's. By, we take m common in this. So, 1 by rho 1 plus 1 by rho 2. And this will be equals to, here we can cancel m, right? So, 2 by, and we can simplify this as rho 1 plus rho 2 by rho 1 rho 2. I hope you all know the LCM. So by that we can simplify this, and this will be equals to, means when we reciprocal this, we get 2 rho 1 rho 2 by rho 1 plus rho 2. Yeah. And if the volumes are same, then what do we do? If we know only the volumes and density of the substance, and if the volumes are same in both the substances, how do we solve it? I'll show you. See, for that I have showed you how to solve the volumes right here. So we have to use this formula, but in place of V1 and V2 we have to take the same value. That means V1 rho 2, V1 rho 1 plus V2 rho 2 by V1 plus V2. Here volume is same, no? So this will be just V. So this will be equals to, and we can take V common here. So rho 1 plus rho 2 by adding 2 V's we get 2 V. So V gets cancelled, and this will be equals to rho 1 plus rho 2 by 2. Yeah. Those were a little bit tricky but a fun part. And now let's see the other important factor in fluid mechanics, which is so important to understand fluid mechanics better. That is thrust. Thrust means a force acting on an object in normal direction. What does normal mean? Means it should be in this direction to the object. It should not be like this or anything. So it should be in this direction. Then it is called thrust. So thrust is the force acting on an object in normal direction. So as thrust is a kind of force, the SI unit, CGS unit, everything is similar for thrust and force. That means SI unit of thrust is Newton, which means kilogram meter per second square. And CGS unit will be dyne, which means gram centimeter per second square. And thrust is a vector quantity. And why did I tell you about the thrust? Because it is important in topic pressure. So thrust is an important topic first, which you have to understand to know about pressure. Because pressure means the thrust acting on an object per unit area. So we write it as thrust by area. So pressure is equals to thrust by area, and the SI unit of pressure is taken as Pascal. Pascal is actually a scientist. He has discovered the transformation of pressure in fluids. So in honor to him, SI unit of pressure is taken as Pascal. And we write it as, what will be the SI unit of thrust? As we know, kilogram meter per second square and area, meter square. So m, 1m and 1m get cancelled. So kilogram per second square by meter. So, and pressure is a scalar quantity. And do you know a fact that a pressure is acting on us right now, but we can't feel it, right? Yeah, it is atmospheric pressure. The pressure acting on us, not only just on us, the atmospheric pressure acts on every object on the earth. It is the pressure exerted by Earth's atmosphere on us. Why we can't feel it? Because it's of a light pressure, and that pressure is exerted by air molecules, atmospheric gases on us. And atmospheric pressure at sea level is 1.013 into 10 power 5 Pascal. And apart from atmospheric pressure, there is other important pressure called gauge pressure. What does gauge pressure actually mean? It is the pressure exerted by an object on the other object more than the atmospheric pressure. For example, take an object and I am pushing the object downwards. Then I have exerted some gauge pressure on this. That means it is more than the atmospheric pressure. So the total pressure acting on this object will be the atmospheric pressure as well as the pressure I am exerting on it. So that will be gauge pressure plus atmospheric pressure. And that pressure, the total pressure is called absolute pressure. So the total pressure will be absolute pressure. And let's see mathematical expression of pressure in fluids and depth. Let's take a big container filled with liquid, and the object is dipped into it. And this object is exerting some pressure on the bottom of the beaker, right? How to find it? First, let me tell you the values of this. The cross section area will be A, height will be H, and this area will be capital A, and this height and density of this is taken as rho, and density of this will be taken as rho 2 and this one rho 1. Okay, let me show you. First, we have to find the pressure of this. What does pressure mean? As I told you, thrust by area. So to find this, we have to know the thrust first. So how to find the thrust? Thrust is equals to mass into gravity. And how we don't even know the mass of it. And how do we find the mass? Mass is equals to volume into density. So volume will be is equals to area into height, AH. And density, we take it directly, 1. And we got the value of mass. So we have to multiply with gravity to get thrust. We write it as AH rho into G. This is the value of thrust in this case. And to find the pressure, we divide it by area. So A get cancelled and it will be H rho G. So by this we can tell that pressure is dependent on height, density, gravity and independent of area. And the next one is Pascal's law. Pascal's law states that when a pressure is exerted on an enclosed fluid, the pressure will be transmitted undiminished to all portions and to the walls of the container. That means when pressure is exerted on an enclosed fluid, the pressure will be spreaded and means the pressure will act equal in all directions of the liquid and as well as it acts in all directions of the container. That's Pascal's law. And buoyancy. What does buoyancy mean? Buoyancy means the upthrust experienced by an object when immersed into a fluid. So, when you take an object, it may be of lightweight or heavy, anything, when you immerse it in a liquid, you just experience a force acting against you, pushing the object upwards, right? Yeah, that force is called buoyancy. And buoyancy is calculated as, buoyancy is also a kind of force, right? So, we take the buoyancy as we know, pressure is equals to force by area. That means force is equals to pressure into area. So we got the pressure exerted by this liquid, right? That was rho G H and into area. So into area. If we multiply that, we get, as we know, H into A. That means height into area, we take it as volume. So we write in the place of HA, V. That means Owen's force is equals to rho G into volume of that substance. And the next one is Archimedes' principle. There is a historical story behind Archimedes' principle. I'm going to tell you in a very brief way. Once there was a king in a kingdom who was a great warrior. He won many wars and he was so happy about himself, and he thought to prepare a golden crown for, not for him, for God's sake. He wanted to offer a golden crown for God. So, as the king is so rich, he called the great goldsmith in that kingdom and ordered him to prepare a golden crown. And after a few days, the goldsmith prepared a beautiful golden crown and presented it in front of him. But when king has showed it to everyone in the kingdom, some people started to murmur that I think the golden crown might be like not made of pure gold, or it may be something non-real. So the king got very angry about it, and his favorite physicist mathematician was Archimedes right there. So he called out Archimedes immediately and ordered him that within 6 days you have to find whether this crown is made of real gold or not. Archimedes he got a solution. Like king gave a 1 kg block of gold to the goldsmith and ordered to make that. But if the result of that gold means the crown made now is same of the density of the first initial gold, then it both will be same. If the density is differed, then the uh, crown will be made of impure gold. So he thought to find it. As we know, density is equals to mass by volume. But we can know the mass of the crown easily. But what about the volume? Though Archimedes was a great mathematician who was so professional and expert in finding the volumes of cuboid, cube, and other geometrical shapes, but crown, see, crown is an irregular shape, right? We can't find the exact volume of that. So he was so confused, and king had ordered him to complete his task within 6 days. The Archimedes was so tense and he tried many things, but he was not successful. At the final fifth day, one he thought, okay, tomorrow I'm going to die, so let's enjoy my life for the last day. And he ordered the people to give him a big bathtub and just he want to relax in it for some time, like he's gonna die tomorrow, right? So, and when he like the bathtub was completely filled with water till its brim, and when Archimedes entered into this, the water splashed out. What made the water splash out? Yeah, that was the question arised in Archimedes' brain. Then he understood that there is a force acting on this, and that force has displaced water from the bathtub. So he shouted, Eureka! He got that, and he told that when an object is placed in a liquid, the water get displaced, which is equals to the buoyancy acting on that object. So the next day he came to the kingdom very happily and brought a big measuring beaker with him, and he measured the water at the initial state. Then he added the crown into that, and the water had rise to certain level. He had measured that. Now he found the value of volume of crown. So by finding the volume of crown, he had substituted with the density, he had done the calculations, and he found out that the density of this crown was not equal to the initial density of the gold given by the king. So he had expressed this everything to the king, and king got angry on him and he killed the goldsmith after that. And this was a funny story. I hope by this story you understand the Archimedes principle. And other final topic is, as I told you before, a large boat floats on top of sea, but a small stone gets sink into it. See, we feel like, what's the logic behind this? How can a large one float while a small one gets sink, right? That's the thing in flotation, sinking, and everything. I'll tell you clearly. See, if we have a liquid and its density is rho L. I kept L as I took the density of the liquid, and take an object like take a wooden cork of density rho S. Wooden cork is solid, right? So I took rho S. So if you place this here, as we know, wooden cork is of less weight, and also wooden cork's density will be less than liquid's density. So wooden cork's density will be less than liquid's density. So in this case, the wooden cork floats on the water. And if you take other object like a iron nail, its density will be greater than density of liquid, right? So then it gets immersed into the water. And take other any object like a plastic cube or anything. Just for example, in any case, when rho s is equals to rho l, what happens? Yeah. See, when rho s is equals to rho l, the object will not means it gets will not sink into the water, or it won't even float completely on top of the water. It will float right here. Means if the water level is still here, it get immersed, but it floats at the top of the water. So this is the reason behind ships floating on the sea water while a small stone gets sink into it. That means the density of this ship is less than the density of the sea water below it. So the ship floats. But the density of a stone is more than the water. So the stone gets sink. So I hope the first doubt of you was clarified, and I think the fluid mechanics topic is very interesting, funny, and so nice to learn. And this is for today. I hope you understood my teaching, and I'm so thankful to respected principal ma'am and our AD sir Hariprasad sir to give me this golden opportunity. I hope you had a lot of fun hearing. Thank you.